What is going on, coders? Welcome back to this Python 3 channel. In today's video, we're going to take a look at generators versus for loops. And we're going to determine how memory efficient each one of them is and how long it takes to execute each one. So let's dive into the code. Let's take a look at lines 1 and 2. First off, we import the sys module as well as the timeout module. The sys module will help us determine how much memory is being used by the for loop and generator respectively, as well as the timeout module will determine how much time it takes for each one of them to execute, so that we can compare execution time as well. So going further down, we've got on line 4, we've got the number 1 million. And on line 6 and 7, we've got a function definition called for loop. What we're going to do is we're going to pass the number 1 million to this for loop, and we are going to return a list which will square each number from 1 to 1 million, and then that list will be returned. Now, going further down, we've got pretty much the same thing, however, written as a generator, which means that we will again go through all of the numbers from 1 to 1 million. However, we will at the end yield the result of the square. Now, moving down to lines 13 and 14, what we're going to do is we're going to define variables which will store the size of in memory of the for loop as well as the generator. And then on lines 16 and 17, we're going to time how much time actually it takes for the for loop and the generator. Obviously, we're going to need to modify the generator to return a list here in order for it to be more accurate. We're going to determine how much time actually it takes, and then at the end, at the bottom here, it will show us how much time and memory is allocated to both. So let's take a look at the results. Right, so if we look at the for loop memory in bytes, we can see that that's 8,697,456 bytes in memory. That's how long or how big the list of numbers, of squared numbers, is actually going to take in terms of space. And then if we look at the generator memory, however, we can see that it's 112 bytes. So the for loop actually takes significantly larger chunk in memory than the generator. I mean, obviously I expected this result, but I wanted it to really be illustrated with numbers. So then further down, we're going to look at the for loop time and the generator time. And as you can see here, what we're actually doing is we're passing in the number 1 to the for loop, as well as the generator, we're passing in the number 1. This is for time efficiency reasons. I think if we were to just make this 10 or run 100, it would take significantly longer to execute. So we can see that the for loop time actually took 0.15 seconds, and the generator time took 0.17, nearly 169 seconds. So the generator actually will take longer, especially when we are actually comparing this list here, or this, we're casting the results as a list. So I think this also has a detrimental effect on how much time actually this will take. But yeah, overall, I think the thing to take away from this video is that generators are significantly more memory efficient, and when you're dealing with large data sets, you should most definitely go for them instead of trying to loop through whatever data it is that you are looking at. I hope you find this video useful, and I will see you in the next one.